My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Unix programming as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: define kernel and shell. In Unix, kernel and shell are like the heart and the face of the operating system. Both are important, but they do different jobs. Kernel, brain of the OS. The kernel is the core part of Unix. It controls all important activities like managing memory, handling files, controlling hardware, keyboard, CPU, disk, managing processes. You cannot talk to the kernel directly. It works silently in the background. Example: when you run a program, the kernel decides how much memory it needs. Shell, interface for the user. The shell is a command interpreter. It allows you to type commands and sends them to the kernel. So, it acts like a middleman between you and the kernel. Example: when you type ls, the shell reads this command, sends it to kernel, kernel fetches file list, shell displays it to you. Easy way to remember. User shell, kernel hardware. Shell is your helper, kernel is the boss inside. Next important short question is: 2. What is a regular expression? A regular expression, regex, is a special pattern used to search, match, or filter text. It is like giving the computer a smart search formula instead of normal words. Regular expressions are used in Unix tools like grep, sed, and awk to find specific text quickly. Why do we need regex? It helps when we want to search specific words, patterns, numbers, dates, mobile numbers, email IDs, etc. Examples, very easy. 1. To find any word starting with A. 2. To find all numbers 0 to 9. 3. To match any 10-digit mobile number 0 to 9, $10. 4. To find words ending with ing. $. Easy way to remember. Regular expressions is equal to smart patterns for searching text. Instead of searching manually, regex searches faster, smarter, and more accurately. Next important short question is: 3. What is the significance of file permissions in Unix? In Unix, file permissions are very important because they protect files from unauthorized access. They decide who can read, who can write, and who can execute a file. This keeps the system safe, just like a lock keeps a room safe. 3 types of permissions. 1. R. Read, you can open or view the file. 2. W. Write, you can edit or change the file. 3. X. Execute, you can run the file program. 3 categories of users: owner, group, others. Each category has its own permissions. Example: if a file has permission, it means owner RWX can read, write, execute. Group RX can read, execute. Others R can only read. Why is it significant? File permissions prevent accidental changes, unauthorized access, misuse of programs. Easy line to remember. Permissions decide who can do what with a file. Next Unit 1. Long questions. First important long question is: explain Unix architecture with a neat diagram. Unix architecture is very simple and powerful. It is built in 4 main layers, each doing a specific job. To understand it easily, imagine a hotel system. Customers, users. Waiter, shell. Chef, kernel. Kitchen items, hardware. The waiter takes your order and passes it to the chef. Similarly, the shell takes your commands and passes them to the kernel. Unix architecture diagram, simple ASCII diagram. Explanation of each layer. 1. User applications. These are the programs or commands you use every day. ls, cd, cat, grep, vim, etc. They cannot directly communicate with hardware, they need the shell. 2. Shell, command interpreter. The shell is the middleman between the user and the kernel. When a user types a command, ls, the shell reads it and asks the kernel to execute it. Popular shells bash, cone shell, C shell. 3. Kernel, heart of Unix. The kernel controls everything inside the operating system. File management, memory allocation, process creation and scheduling, device, keyboard, mouse, disk, control, security and permissions. It is like the chef in a hotel, working in the background and doing all the main tasks. 4. Hardware. This includes CPU, RAM, hard disk, input-output devices. Kernel directly talks to hardware using device drivers. Easy way to remember the architecture. User shell kernel hardware. Shell talks to kernel, kernel talks to hardware. Next important long question is: 2. Describe in detail about the structure of Unix file system with a neat diagram. The Unix file system is like a big tree that organizes all files and folders in a simple and structured manner. Everything in Unix files, directories, devices is arranged under one single root directory. This design makes Unix neat, clean, and easy to manage. Neat diagram of Unix file system, simple ASCII. Main components of Unix file system. 1. Root directory. This is the topmost directory. All other directories grow under it like branches of a tree. Example: home, etc. Bin. 2. File system types inside Unix. Boot block. First block of the file system. Contains instructions required to boot the system. Used when the computer starts. 2. Super block. The super block contains important information like file system size, number of free blocks, number of free inodes, block size. If this gets corrupted, the file system becomes unreadable. 3. Inode table. An inode stores all information about a file except the file name. It contains file size, file permissions, owner info, timestamps, location of data blocks. Every file has a unique inode number. 4. Data blocks. These blocks contain the actual data of the file. Example: if a file contains Hello India, these words are stored inside data blocks. Important directories in Unix. Bin contains basic commands like ls, cp, mv, etc. contains system configuration files. Home contains user home directories. Dev contains device files, printers, USB, hard disk. TMP temporary files. Easy way to remember. Think of the Unix file system as boot block, super block, inode table data blocks, and root subdirectories files. This structure makes Unix organized, secure, and very fast for accessing files. Next important long question is: 3. explain different types of files supported in Unix. In Unix, everything is treated as a file: text, programs, devices, sockets, pipes, everything. To keep the system simple and powerful, Unix supports 6 major types of files. Understanding these file types makes it easy to work with commands, permissions, and system tasks. 1. Regular files. These are the most common files in Unix. They contain normal data such as text, images, or program code. Examples: text files, notes.txt; program files, hello.c; documents, report.pdf; command to check type, file my file. 2. Directory files, D. A directory is like a folder. It stores the names and inode numbers of files inside it. Example: home, etc. bin, use, lsl. You will see D at the beginning for directories. 3. Character device files, C. These files represent devices that send data character by character. Examples: keyboard, mouse, serial ports. These files are stored inside the dev directory. Example device file: dev tty. 4. Block device files, B. These devices transfer data in blocks, which makes them faster. Examples: hard disk dev sada, pen drive, CD DVD drives. 5. FIFO named pipes, P. FIFO stands for first in, first out. It allows two processes to communicate. Example: create a pipe, mkfifo my pipe. One process writes data, another reads it. 6. Socket files, S. Used for network communication between processes. Sockets allow data exchange over local or network systems. Example: Unix desktop apps use socket files inside run or tmp. How to check file types? Use lsl. Look at the first character. Regular file. D directory. C character device. B block device. P pipe. S socket. Easy way to remember. RDCBPS: regular, directory, character, block, pipe, socket. These types make Unix powerful, flexible, and perfect for developers and server systems. Next important long question is: 4. Explain the use of mod command to change file permission using both absolute and relative methods. Abid Sir YouTube channel. In Unix, every file has permissions that control who can read, write, or execute a file. To change these permissions, we use the chmod command. Chmod stands for change mode. There are two methods to change permissions. 1. Absolute, numeric, method. 2. Relative, symbolic, method. 1. Absolute method, using numbers. In this method, we use numbers to set permissions. Each permission has a value. Permission value: R. Read 4. W. Write 2. X. Execute 1. We add these numbers to set permissions. Format: mod NNN file name. NNN is equal to owner, group, others. Example: give full permission to owner, read plus execute to group, read only to others. Owner: 4 plus 2 plus 1 is equal to 7. Group: 4 plus 1 equals 5. Others: 4 is equal to 4. Command: mod 754 notes.txt. Permissions become rwxrxr. 2. Relative method, using symbols. This method uses characters instead of numbers. Symbols used: U user, owner. G group. O others. A all, U plus G plus O. Plus add permission. Remove permission. Is equal to set exact permission. Example 1, add execute for user. Mod U plus X script.sh. Example 2, remove read permission from others. Mod or file.txt. Example 3, give read and write to group. Mod G plus rw project.doc. Example 4, set exact permissions for all. Mod A is equal to our file.txt. Everyone gets read only. When to use which method? Use absolute numbers when you know exact permission values. Use relative symbols when you want to add or remove specific permissions. Easy trick to remember. Absolute numbers. Relative letters. Mod makes Unix files safe, secure, and controlled, allowing only the right people to access them. Next important long question is 5. Discuss about grep with suitable examples. The grep command in Unix is one of the most powerful and commonly used commands. The word grep stands for Global Regular Expression Print. In simple words, grep is used to search text or patterns inside files. It shows only the matching lines, which makes searching very fast. Why do we use grep? To search a word inside a file. To filter results. To find patterns using regular expressions. To ignore case. To count matches. To search in multiple files. Basic syntax. Grep pattern file name. 1. Simple search example. Search the word India in notes.txt. Grep India notes.txt. Output will show all lines containing India. 2. Case-insensitive search, I. Grep I apple fruits.txt. Matches apple, 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 etc. 3. Show line numbers, n. Grep n error log.txt. Shows which line contains the word error. 4. Search in multiple files. Grep root etc. psswd etc. group. 5. Display lines that do not match pattern v. Grep v success report.txt. Shows all lines that do not contain success. 6. Count the number of matches, c. Grep c Unix notes.txt. Shows how many lines contain the word Unix. 7. Using regular expressions with grep. Search lines starting with A. Grep A words.txt. Search lines ending with ing. Grep ing $data.txt. Search any digit. Grep 0 to 9 sample.txt. Different versions of grep. Grep normal search. Grep extended regular expressions. Fgrep fixed strings, no regex. Easy way to remember grep. You ask, grep finds. It is like Ctrl plus F but much more powerful, fast, and used by programmers daily. Grep makes searching huge files easy, quick, and super efficient in Unix. Next important long question is 6. What is grep? List and explain about its family commands. The grep command is one of the most useful and popular commands in Unix. The name grep comes from Global Regular Expression Print. In simple words, grep is used to search for words, patterns, or lines inside files. It shows only the lines that match your search, making it very fast and powerful. What does grep do? Searches for a word or pattern. Filters text. Works with regular expressions. Helps find errors in logs. Searches inside multiple files. Basic syntax. Grep pattern file name. Example. Search the word error in logfile.txt. Grep error logfile.txt. Grep family commands. There are 3 members in the grep family. 1 grep basic regular expression search. This is the standard grep command used for normal searching. Example. Grep apple fruits.txt. Searches lines containing apple. To a grep extended grep. A grep means extended grep. It supports extended regular expressions, array, like plus, vertical bar, and. Example. A grep cat vertical bar dog pets.txt. Shows lines containing cat or dog. Another example. A grep a plus data.txt. Matches lines with one or more a. 3 fgrep fixed grep. Fgrep means fixed grep, also called grep f. It does not treat characters as regular expressions. It searches for the exact string, even if it has symbols. Example. Searching for a line containing a plus b. Fgrep a plus b file.txt. It treats plus as a normal character, not regex. Quick comparison table. Command meaning supports regex. Use. Grep basic grep yes normal searching. Agrep extended grep yes advanced complex patterns. Fgrep fixed grep no exact string search. Easy way to remember. Grep is equal to normal. Agrep is equal to advanced. Fgrep is equal to fixed. Together, the grep family makes searching in Unix powerful, fast, and super useful for programmers and system admins. Next important long question is 7. What is AWK programming in Unix? Explain its syntax, working, and give examples where AWK can be used effectively. AWK is a very powerful text processing and data processing tool in Unix. The name AWK comes from the initials of its creators, Aho, Weinberger, and Kernel. In simple words, AWK reads data line by line, breaks each line into fields, and performs actions on those fields. It is mainly used for reports, filtering, and formatting text. Why is AWK useful? It can pick specific columns from a file. It can perform calculations. It can generate reports. It works perfectly with structured data like CSV, logs, and tables. Basic syntax of AWK. AWK pattern, action, file name. Meaning. Pattern what you want to find. Action what you want to do with that matched line. If no pattern is given, AWK applies action to every line. How AWK works? Simple steps. 1. It reads the file line by line. 2. Splits each line into fields using a delimiter, default is equal to spaces. 3. $1 is equal to first field, $2 is equal to second field, $0 is equal to whole line. 4. Executes the given action. 5. Prints the output if required. Important AWK variables. $0 entire line. $1, $2, $3 fields. NF number of fields. NR current line number. FS field separator. Examples of AWK. 1. Print the first column of a file. AWK, print $1 students.txt. 2. Print first and third column. AWK, print $1, $3 data.txt. 3. Print lines where salary 50,000. AWK $3 50,000, print $0 employees.txt. 4. Find total of a numeric column. AWK sum plus is equal to $2 and print total sum, sales.txt. 5. Change field separator, CSV file. awk print $1 marks.csv. Where awk is used effectively? Processing student marks. Generating salary reports. Analyzing log files. Extracting columns. Calculating totals and averages. Easy way to remember awk. awk is equal to pick process print. It makes text processing simple, powerful, and super fast in Unix.